Hi students, this is the fifth lecture of Fourier integral and transform. In the previous lectures we have learned Fourier sine integral, cosine integral and Fourier transform. In this lecture we are going to learn Fourier sine and cosine transform. As in the previous lecture we have learned Fourier transform, which is defined for minus infinity to plus infinity. That is the whole line it is defined. But the Fourier sine and cosine transform is defined only for positive terms, that is from 0 to infinity. So first we define what is the Fourier sine and cosine transform. So suppose f of x is a real line defined on the positive real line, close 0, open infinity, satisfying the conditions of Fourier transform. The Fourier cosine transform of f of x is denoted by fc f of x or fc cap omega and is defined as fc f of x equal to root 2 by pi integral 0 to infinity f of x cos omega x dx, and the inverse Fourier cosine transform is given by fx equal to root 2 by pi integral 0 to infinity fc f of x cos omega x dx. That is, this is the same Fourier transform that is we have learned earlier. We have learned earlier Fourier transform which contains both sine and cosine term, but here we specify defines what is Fourier sine transform and what is Fourier cosine transform. And here the difference is that here we are defining the function for the only for the positive terms, that for 0 to infinity, and the condition will be same, that is it must be piecewise continuous and the absolute function should be integrable. If these two conditions are satisfied, then we can express every function as a Fourier cosine transform, and it can be represented as in two ways. The first one is fc f of x or fc cap omega, and it's defined as fc f of x equal root 2 by pi integral 0 to infinity f of x cos omega x dx. That is, if a question is to find the Fourier cosine transform, the formula is simply write the cos term, that is function into cos omega x with respect to x, limit is 0 to infinity. And for this is a Fourier cosine transform, and correspondingly we can write the Fourier inverse cosine transform, that is given by fx equal to 2 by pi integral 0 to infinity fc f of x cos omega x d omega. Fourier cosine transform we are integrating with respect to x, and the inverse Fourier cosine transform we are integrating with respect to omega, and this function is used to find the corresponding function from a Fourier cosine transform. That is, if we know a Fourier cosine transform, then by using this inverse formula we can find the corresponding function f of x. Similarly, we can define Fourier sine transform and inverse sine transform, and the Fourier sine transform is denoted by fs f of x or fx cap omega, and is defined as fx equal to root 2 by pi integral 0 to infinity f of x sine omega x dx, and the inverse Fourier sine transform is given by f of x equal to root 2 by pi integral 0 to infinity fx f of x sine omega x d omega. The formula is same, only the difference is that here it is sine term and here it is cosine term. So these are the formula for finding Fourier cosine and sine transform. That is, if in the question it is specifically given that which formula is used, that is use Fourier cosine transform to find or use Fourier sine transform to find. If it is cosine transform, use the cosine transform formula. If it is sine transform, use the sine transform formula. And the inverse cosine and sine can be also represented as fc cap or fx cap, either f of x, or this means Fourier cosine transform, inverse Fourier cosine transform, inverse Fourier sine transform. So these are the formulas that you have to study, that is a Fourier cosine transform, the corresponding inverse formula, Fourier sine transform and the corresponding inverse formula. Now we will do some problems of these transforms. The first question is, find the Fourier cosine and Fourier sine transform of fx equal to k 0 less than x less than a and 0 x greater than a. Question is to find both the Fourier cosine and Fourier sine transform. First we write the Fourier cosine transform formula. It is given by fc f of x equal to root 2 by pi integral 0 to infinity f of x cos omega x dx. This is the Fourier cosine transform formula. Now we define the function from the given question, and the given question function has two values, k for 0 to a and 0 for x greater than a. So this limit, the function exists only in the limit 0 to a. So this limit changes to 0 to a, and the corresponding function is k. That is root 2 by pi integral 0 to a k cos omega x dx. Now k is a constant, we can take it outside, so root 2 by pi k into integrating cos omega x with respect to x. Integral of cos is sine, so sine omega x divided by derivative of omega x with respect to x is omega. So integral of cos omega x is sine omega x by omega, and the limit is 0 to a. Now we have to apply upper limit x equal to a and lower limit x equal to 0. So it becomes sine omega a minus sine 0. We can take this omega outside. So answer is root 2 by pi k by omega sine omega a minus sine 0. And sine 0 is 0. So answer is k in root 2 by pi sine omega by omega. Similarly, we can find Fourier sine transform. Only the difference is that in formula cos is replaced by sine. That is Fourier sine transform of x equal to root 2 by pi integral 0 to infinity f of x sine omega x dx. Here also function is defined only for the limit 0 to a and the corresponding value is k. So k sine omega x dx. Now k is a constant, we can take it outside, and integral of sine, we know that it is minus cos, so it is minus cos omega x divided by derivative of omega x with respect to x is omega, limit is from 0 to a. Then we can take this omega outside and minus also outside, then applying upper limit x equal to a, so it is cos omega a, lower limit 0, that is cos 0. We know that cos 0 is 1, so it becomes minus k by omega root 2 by pi cos omega a minus 1. So answer is, multiplying this minus inside, it becomes root 2 by pi k 1 minus cos omega by omega. Now moving to the second question, find the Fourier cosine transform and sine transform of fx equal to e raised to minus ax, x greater than 0, a greater than 0. So similarly as in the above problem, first write the cosine formula, that is root 2 by pi 0 to infinity f of x cos omega x 0, and here the function is e raised to minus ax and x value starting from infinity, and since the upper limit is not given, we take it as the maximum upper positive value is infinity, so we take the same limit, that is 0 to infinity, and the function value is e raised to minus ax cos omega x dx. By applying the reduction formula of exponential, we know that e raised to ax cos bx is e raised to ax by a square plus b square into a cos bx plus b sin bx. Here a is minus a, b is omega, and so it becomes e raised to minus ax by minus a the whole square plus omega square minus a cos omega x plus omega sin omega x. Now we can apply upper limit infinity. We know that e raised to minus infinity is 0. So completely this term becomes 0. Now applying the lower limit, so it becomes e raised 0 by a square plus omega square minus a cos 0 plus omega sin 0. And sin 0 is 0 and cos 0 is 1. So it's minus minus plus, and we get a by a square plus omega square. So cosine transform value is root 2 by a square plus omega square. Similarly, we can find Fourier sine transform. That is, Fourier sine transform formula is root 2 by pi integral 0 to infinity f of x sine omega x dx. Here also the function is same, e raised to minus ax, and limit is 0 to infinity. And by applying the reduction formula, e raised to ax sine bx dx, that is e raised to ax by a square plus b square into a sin bx minus b cos bx. Here a is minus a and b is omega, so it becomes e raised to minus ax by minus a the whole square plus omega square minus a sin omega x plus minus omega cos omega x. Here also applying the upper limit infinity, we know that e raised to minus infinity is 0, so this becomes 0, and applying the lower limit 0, e raised 0 by a square plus omega square minus a sin 0 minus omega cos 0. Sin 0 is 0, cos 0 is 1. This minus minus plus, so answer is root 2 by pi omega by a square plus omega square. This is an important question. These questions appears in the previous question papers. Fourier sine and cosine transform of e raised to minus x. Now moving to the next question. Find the Fourier sine transform of fx equal to 3x. X value varies from 0 to x. So first write the Fourier sine transform formula, that is root 2 by pi integral 0 to infinity f of x sine omega x dx. And here we say that see that here the function is 3x and x value varies from 0 to 6. So this limit changes to 0 to 6, and the function value is 3x sine omega x dx. We can take 3 constant, we can take it outside, so 3 in root 2 by pi. Now applying integration by parts, that is a formula that is we are learning Fourier series. First term into integral of second minus derivative of this term into integral of second. That is, here the first term is x. Integral of second means integral of sine omega x with respect to x is minus cos omega x by omega. Then put a minus sign. Then take the derivative of x, that is 1. Then take the integral of minus cos omega x by omega. It is a minus sign. Put the minus sign here. Integral of cos omega x is sine omega x by omega. It is an omega is here, so it becomes sine omega x by omega square. Next term derivative will be equal to derivative of 1 become 0. And apply the limit 0 to 6. That is, apply the upper limit 6 and lower limit 0 to x. So it becomes minus 6 cos omega 6 by omega. This minus plus sine omega 6 by omega square. When we apply x to 0, the lower limit, this term becomes 0 and this sine 0 become 0. So answer is 3 into 2 by pi sine 6 omega by omega square minus 6 cos omega 6 by omega. Now moving to the fourth question, find the Fourier sine transform of e raised to minus mod x, and hence show that integral 0 to infinity x sine mx by 1 plus x square dx is pi by 2 e raised to minus m greater than 0. So first we have to find the Fourier sine transform, and then applying the inverse Fourier sine transform formula we have show this integral. So the inverse Fourier formula is applied when the question contains show that question together with the transform formula, that is find the Fourier cosine transform, hence show that. That is, if the question contains a show that question, then we have to apply corresponding inverse transform formula. So first we have to find the Fourier sine transform of this term, and the formula is fx equal to root 2 by pi integral 0 to infinity f of x sine omega x dx. Function is e raised to minus mod x. Since the function is defined only for 0 to infinity, here the interval is not given, so we take the default integral limit of the Fourier sine, that is 0 to infinity, and 0 to infinity the modulus value mod x is always positive. Then since 0 to infinity means always positive value, this mod x changes to simply x e raised to minus x sine omega x dx. Then applying the reduction formula as told earlier, it becomes e raised to minus x by minus 1 square plus omega square minus sine omega x minus omega cos omega x. Limit is 0 to infinity. Applying the upper limit infinity, this becomes 0. Applying the lower limit 0, it becomes e raised 0 by 1 plus omega square minus sine 0 minus omega cos 0. And sine 0 is 0, so this becomes omega by 1 plus omega square. So we have found out the Fourier sine transform of e raised to minus x. Now we have shown this one. So I have told earlier, whenever a question contains a show that term together with the transform, we have to apply inverse Fourier transform, corresponding inverse Fourier transform. Here it is a question is Fourier sine transform. To show this one, we are use inverse Fourier sine transform. So we write the formula for inverse Fourier sine transform, that is root 2 by pi integral 0 to infinity fs f of x sine omega x dx. This function is already we found out, that is root 2 by pi omega by 1 plus omega square. So substituting the value here, this root 2 by pi become 2 by pi omega by 1 plus omega square sine omega x dx. So now we compare the given obtained integral with the question. So question shows that we need x sine mx by 1 plus x square. That is, question is x sine mx by 1 plus x square. So we have to convert this omega to x. So put omega x equal to x, then x by 1 plus x square sine mx. That is, we have changed x to m. Since simply changing the variable, there is no change in the derivative, it simply changes to dx. D omega means dx. So we to deduce the formula, deduce the value to the given question, we replace this omega by x and x by m. So substituting the value, we get left side is f of m equal to 2 by pi integral 0 to infinity. Omega is changed to x by 1 plus x square. This x is changed to m and this one by x, so mx dx. And we know that f of x is e raised to minus mod x, so f of m is e raised to minus mod m into 2 by pi integral 0 to infinity x by 1 plus x square sine mx dx. We in the question we need only this integral, so this integral become, taking this 2 by pi to the left side, it become pi by 2. Since given that m is greater than 0, this value is always positive, so it become e raised to minus m. So this type of question, that is I have told earlier, that is if along with the question, if there is a show that or prove that question, we have to apply the corresponding inverse transform formula. Remember, don't forget, that is simply sine transform means apply the transform formula. If together with that, if there is a show that or prove that question, apply the corresponding inverse transform formula. It's an important question. Now we move to the next question. Find the Fourier cosine transform of e raised to minus 2x cos x. So first we write the cosine transform formula, that is root 2 by pi 0 to infinity f of x cos omega x dx. And here the function is interval is not given, so we take the default integral 0 to infinity, and the function value is e raised to minus 2x cos x cos omega x dx. We cannot integrate this one, so yes, we have to convert this cos a cos b term. That is 2 cos a cos b is cos a plus b plus cos a minus b. Here a is x and b is omega x. Substituting the value, that is half of, there is no two terms, so cos a cos b is half of cos x plus omega x plus cos x minus omega x dx. And we can take this x term outside and separating e raised to minus 2x with separating each term. So it becomes 0 to infinity e raised to minus 2x cos x plus 1 by omega x dx plus 0 to infinity e raised to minus 2x sine 1 minus omega x dx. Now we can apply the reduction formula separatively to the integral. In first term, a is minus 2, b is 1 plus omega. So e raised to minus ax by a square plus b square into a cos bx plus b sin bx. Again second term, a is minus 2 and b is again 1 minus omega. So e raised to minus ax by a square plus b square into a cos bx plus b sin bx. And applying the upper limit infinity, we know that e raised to minus infinity is 0. So upper limit is 0. And applying the lower limit 0, it becomes e raised 0 by 4 plus 1 plus omega square minus 2 cos 0 plus 1 by omega sin 0. Here also when we apply the upper limit, it becomes 0. And when we apply the lower limit 0, it becomes e raised 0 by 4 plus 1 minus omega square minus 2 cos 0 plus 1 by omega sin 0. We know that sin 0 is 0 and cos 0 is 1. And simplifying and taking the term two term outside common, this we get the answer as root 2 by pi 1 by 4 into 1 plus omega square plus 1 by 4 into 1 minus omega square. Now next question, find the Fourier sine transform of f of x equal to x 0 to 1, 3 minus x, 1 to 3 and 0, x greater than c. In this question only the difference is that the function has divided into 3 intervals, that is in between 0 to 3, and it has 3 values. From 0 to 1 the value is x, and 1 to 3 the value is 3 minus x, and for greater than 3 the value is 0. So when we define when we substitute the value, we have to separately give the integral value. That is, Fourier sine transform formula is root 2 by pi 0 to infinity f of x sine omega x dx. And here f of x has 3 values. 0 to 1 has x. So first we have tried 0 to 1 x function is x sine omega x dx plus. Next one is 1 to 3. The value is 3 minus x sine omega x dx. Last one cannot be needed since the value is 0. Now we can apply integration by parts to the both integrals. That is first time in integral of second minus derivative first into integral of second 0 to 1 plus. Here also first time into integral of second minus derivative first into integral of second 1 to 3. Applying the upper limit 3 and first applying upper limit 1, lower limit 0, then applying upper limit 3 and lower limit 1, and simplifying, and we get the answer as minus root 2 by pi 2 sine omega by omega square plus cos omega by omega minus sine 3 omega by omega square.